Hey all, hope you're doing well here. Gonna go over 4 of the review problems and hopefully this will benefit you for the test. Make sure you guys review a lot of stuff, make a note card, and just be prepared. It might take you a good bit of time. So anyhow, here we go. Try to do these as quick as possible. Feel free to speed up the video and skip around as much as you want here. Alright, so we have s prime of t. We're finding instantaneous velocity, okay? So in this problem, you're essentially finding the derivative, okay? And instead of having x as in the normal derivative way of writing it out here, f prime of x, we have t, okay? Instead of f of x, we have s of t. So we're going to do s prime of t. The h is still going to be h, okay? Because this t is representing x here. It's not representing like something else like h. All right, a is just kind of a dummy variable that we have sitting there, like some other constant term. All right, so we still have the limit as h approaches 0. All right, so let me, in place of f of x plus h, we would have s of t plus h. Okay, minus s of t. Now we know t is equal to 3 here, so if you want to, you could just put right here, instead of putting a t in, you could just go ahead and put a 3 in, alright? So I know that's sloppy, but you got the idea there. Okay, so we now need to substitute this 3 plus h in place of the t right here, okay? Because we're doing s of 3 plus h. All right, so we would still have the limit, okay? And then as h approaches 0, I might just put like doodle down there, like ditto, okay? So I don't have to write that every time. But we would have 4 times a, okay? That part stays the same, but we're substituting 3 plus h in place of that t, okay? I know t is equal to 3, but here we're doing s of 3 plus h according to the limit definition here. And this is all squared plus 6. I almost forgot the plus 6 just now. Minus s of 3. S of 3. Now remember, this part should be in brackets because it's like a separate function. All right, and you have to be careful to distribute to it. So it'd be minus 4 times a times 3 squared plus 6. All right, that actually becomes minus 6 after you distribute. So if you don't put those brackets, you might not see that. All over h. All right, so now ditto, it's the limit again. All right, let's go ahead and square 3 plus h quantity squared. So we'd have 4a times 3 squared is 9. Okay, remember we're doing that shortcut. Okay. Shortcut is, a plus b, the quantity squared, and I'll just write it in for you guys, type it in easier, is equal to a squared plus 2ab, because you'd have the same thing on the inner and outer terms. You have to remember to just to FOIL this, okay? A plus b times a plus b will give you this. If you remember the shortcut, that is great. Otherwise, remember you have to FOIL this, okay? So in this particular problem, it would be 3 times h doubled, which is 6h, it's the 2ab part, plus b squared, which is h squared, okay, plus 6. Okay, now over here, let's do some simplifying here. We have 3 squared, which is 9. 9 times 4 is 36, 36a. So we would be subtracting minus 36a, and then you have to remember to distribute that minus sign to the 6, so minus 6 all over h. Okay, so now we can cancel off these 6's, which is nice. All right, we have this limit again. Okay, don't forget, this is all the limit as h is approaching 0 here. All right, because we're going to have to substitute that 0 in at the end to evaluate the limit. All right, so let's go ahead and distribute that 4a in and see what we get. We got 36a, 4a times 6h is 24ah. 4a times h squared is 4ah squared. Then we have minus 36a. Ooh, all over h. Okay, so look, a couple more terms cancel. Minus 36a and 36a cancel. Then we can, remember at this point, it's always good to think, well, what can I factor out to cancel out that h in the bottom? Oh, I just take out a GCF of h. It will cancel out the h in the bottom. Then we would have 24a plus 4ah here. But don't forget, and that's a little ugly. Let me fix that up for you guys. Plus 4ah. Okay. Don't forget, I forgot, I didn't write it here, but I was just being lazy. I didn't forget about it. Okay. This is the limit as h approaches 0. This is the key to wrap up this derivative here. Substitute 0 in, and when you substitute 0 in, this 4ah term will cancel out. And so all this just simply becomes 24a. So that's so pretty, right? Okay, next problem we're going to go over here is an approximating area one, which you can find the exact area by taking the integral, but we're approximating it by using either the LRAM or the RRAM method. And which one is it, LRAM or RRAM? Well, look at the rectangles. Which corner is touching? It's the left corner. So therefore, this is LRAM, okay? So you need to figure out the base of each rectangle and figure out the height of each rectangle. Calculate the areas of all of them, then sum them up, okay? And then you have 4 rectangles, and okay, let's go with the base of the first rectangle. In fact, all of the rectangles have the same base, and that is 1.5. So I'm just going to type in 1.5, okay, for all of the rectangles. Now, it's good to keep track of, how did I know that was 1.5? Well, the difference between 4 and 5.5 is 1.5, and each one is consistently the same base. All right, so the base is really easy to calculate. Now, where I think I lose a lot of you guys is calculating the height. You can't just look at the graph and guesstimate. You have to be precise here when you're finding the height when they give you the function. So you take the point that is touching it, the x value of the point that is touching the curve here, and you substitute it into the function, okay? So if you wrote out all the intervals, which I'm not going to take the time to do, but the interval, when you're doing the left rectangular approximation method, you're using the smaller of all the intervals. So you'd be using the 4, okay, for the first interval. And the next interval, it starts at 5.5, so then you'd be substituting 5.5 in. But you're substituting it into the function to figure out the heights. All right, if you don't do that, then you're not going to get the problems right. You're just kind of guessing, all right? So I hope you're watching this. Well, you are if you heard that. But if you're not watching this, you should text your friends and say, why don't you watch the video? Because, yeah, it's helpful. All right, anyhow, we have 48 minus 16. And you're going to calculate that, 48 minus 16, whatever that might be. All right. Well, that's 32. I can do that mentally. I don't know why I'm trying not to do it mentally. Anyhow, let's do the next interval. F of, okay, so the next interval starts at 5.5. So then you figure out that. Okay, and then you have to do 5.5 squared. All right, and I don't know what that is. I'm not going to bother with this one, but then you do f of 7, okay, because that's where the next rectangle starts, okay? You always are, with the left rectangle approximation method, you're always using the left corner, okay, of each rectangle. Now, if we were doing RRAM, you would be using the right, or the larger of the values on the interval. So we would be doing f of 5.5 first, okay? So, just make sure you're using the right beginning value to substitute in for the height. Okay, and so the final region, you would do f of 8.5. All right, and then you calculate the area by just doing base times height, which I hope you guys probably realize. And then you would sum them all up here. So this one would be 48. I didn't do all these other ones. But, you know, sum them all up, and boom, there's your answer. Okay? So hopefully that's enough to help you with this one. Let's go on to another one here. Graph the integram and use it to evaluate the definite integral. So you have to graph this first. All right, let me explain how I graphed it. First, you know it's a line because it's like y equals mx plus b. My y-intercept is 9. Okay. This is stuff from Algebra 1, so hopefully you guys got that. So here is my 9. Your slope is up 1 over 1. And I'm concerned with the region from -7 to 9 on the x-axis here. Okay. So think about what shape this is. Oh, this is a trapezoid. So remember, I told you you need to know the formula for area of a trapezoid. All right, because what is underneath this line and what is underneath every line? It's a trapezoid. Okay, so it is base 1 plus base 2, and then you're averaging the two bases. You're multiplying it by the height. Okay, the height of the trapezoid. Now this one is a little bit, all of them are kind of a little bit tricky because they're like trapezoids on their side, okay? So we need to figure out base 1 and base 2 first here. So base 1, okay, is just going to be this region right here. That's base 1. Base 2 is this region right here. It's a trapezoid on its side, okay? And how do you get that height right here? Well, it's just like when you're doing LRAM and RRAM. You're going to substitute into the function. So take -7, substitute it in place of 9, or in place of x, and then you would have -7 plus 9. Okay, so you're substituting it into x plus 9. So the height here, mine looks a lot higher, but that's because I didn't really pay attention when I was graphing it. But the height here is actually 2. All right. For B2, you're going to substitute positive 9 in for x. So it'd be 9 plus 9. My height is going to be 18. Well, not my height, but, well, it is the height of this region, but that's base 2, okay? The height is actually the horizontal in this case, so it's a little bit confusing. But the distance from here to here is the height, okay? And so that is 9 minus -7, which is the same as 9 plus positive 7. So my height is equal to 16. Okay, after that, you just substitute it into the formula, and then you just approximated. Actually, this is the exact value of the area, which is kind of cool. It's not an estimate, it's exact here, because you're not using the approximation methods, you're doing an actual formula for the area. Okay, so the height was, what, 16? All right, so you have 20 plus 2, 8. You have 2 plus 18, which is 20, divided by 2, which is 10. 10 times 16. This area is 160 units squared. Okay, well, I was going to do one more problem with you guys, but since I got no comments, actually, I did get one, okay. Nobody said any questions in particular, okay. So that means I guess most of you didn't really care that I made this video anyways, or aren't even watching it now. But I'm glad if you made it this far. Thank you. But hopefully you are good. If you want me to do number 5, I could do it, but it's just another derivative. We've done a lot of videos on those. Just to remind you guys, though, that if a problem asks you to find the slope of the tangent line at a certain point, it's actually asking you the same thing as finding the derivative at a specified point, okay? So just find the derivative, plug in the point, and then you got the slope of the tangent line. Slope of the tangent line is the same thing as the derivative. Okay, so don't let that question just throw you off a little bit. All right, so that's about it. Thanks for watching my video. Make sure to ask me any questions, and I hope you do well on your test. All right, have a great day. Bye-bye.